Okay, students, so let's get started with today's past paper. Today we will be seeing an O-level physics ka ATP. This is October-November 2024, paper 4, variant 1. Let's get started with it. Okay. A student measures the volume of two identical straws. Okay, so he is measuring the volume of two identical straws by different methods. Okay, so we are measuring the volume of two straws by different methods. Here is method 1. The student takes one straw and cuts it into five pieces that are equal in length. अच्छा, ठीक है. So you are taking one straw and you are cutting it into five equal pieces. Perfect. Lines up the pieces of straws are shown in figure 1.1. Ensure the pieces of straws are touching each other. Perfect. Figure 1.1 is drawn to actual size. Perfect. Measure and record the distance x and d to the nearest zero point 0.1 centimeter. How do you have to do it? You have to basically take a ruler or a meter rule and measure this distance d, and you have to measure this distance x. You have to take a meter rule and measure this distance d and x. Obviously, this is a digital format. I don't have a meter rule that I can put it on the screen. So I have already measured it on a physical paper. Your D or your X should come out to be 4.3 centimeters and your D should come out to be 2.8 centimeters. I have already measured it on a physical paper. You guys can also print it out and measure it. Let's further move ahead. Use your value of X in A part 1 to calculate the length of the straw before it was cut into pieces. So basically, you are cutting the straw into five pieces. X is the length of one piece. You are cutting the straw into five equal pieces. The length of each straw is what? 4.3. What will be the total length? If one piece has a length of 4.3 centimeter, five pieces or the complete straw will have a length of what? 4.3 into 5. This comes out to what? 4.3 into 5. This is equals to 21.5. 21.5 centimeter will be a total length of the straw. Use your value of d to determine the diameter of one straw. Give your answer to the nearest 0.01 centimeter. Perfect. So, can you realize d is what? D is the diameter of five straws. Basically, five straws ka diameter is your capital D, and capital D is 2.8. If I want to calculate the diameter of one straw, what will I do? 2.8 divided by 5. This is equals to what? 2.8 divided by 5. This will give you an answer of 0.56 centimeters. Since we have to give it till 0.01 centimeter, it will be 0.56 centimeter as your answer. Nothing complicated here. Let's further move ahead. Explain how the student uses a ruler and two set squares to make sure that the measurement of D is as accurate as possible. You may draw a diagram to help your explanation. Always remember, if the examiner is giving you this luxury to draw a diagram, you must utilize it, especially in the ATP papers. Okay. So, how will the student make sure that he measures D as accurately as possible using what? Using a set square and a D. So, let me snip this image here and let's do one thing. Let's place it here. So, what the student will do, and you can draw this diagram as well. The student will make use of two set squares. The student will make use of two set squares to align these straws. Better, the student will make use of two set squares like these to align the straws. Maybe the set squares can be a bit bigger, but they will be used to align the straws in a perpendicular way, like this. And let's draw the complete set square like this. And let's draw the horizontal line as well, like this. This is the first set square. Perfect. You can place a similar set square on the left hand side, on the right hand side as well. Somewhat along these lines. Control copy, control V. Let's try to flip it if we can. Yeah. Flip horizontal. Yep. So this will be your set square placement. And you will place a ruler along with the set square. You will measure this reading as your D1. You will measure this reading as your D2. Subtract both the readings to get the final answer of D. So how will you explain this? You will say align. Let me zoom in and write the answer. You will say align the set squares perpendicular to the straws. Simple. Align the set of squares perpendicular to the straws and take a ruler or measure and measure D1 and D2 using a ruler. Simple. What will you further say? D is equals to D2 minus D1. Simple. This is what a good student will write here. Perfect. The volume V1 of the straw is given by this equation. The volume V1 of the straw is given by this equation. Perfect. Use your answer to part A2 and A3 to calculate V1. Give your answer to two significant figures. The examiner has specified that you have to give your answer to two significant figures. How will you calculate the volume? Volume V1 is equals to 3.14 into D square. What was the value of D? 0.56. 0.56 square. Perfect. Multiplied by the length L. What was the length L? Length L was 21.5. Perfect. 21.5 divided by 4. What does your volume V1 comes out to be? What does your volume V1 comes out to be? Your volume V1 comes out to be what? 5.3 cm cube till till two significant figures. Your volume V1 comes out to be 5.3 cm cube till two significant figures. Nothing complicated here. Let's further move ahead. Now let's see this. Method 2. The student takes the second straw, immerses the straw fully in a container of water as shown in figure 1.2. Okay. The student immerses the straw completely in water. Okay. Move the straws forward and backwards in the water several times so that the water enters the straw. Perfect. Puts a finger firmly over one end of the straw and remove the straw from the water. Perfect. Puts the straw above the open end of a 50 cm cube cylinder and then remove the finger so that the water is transferred into the measuring cylinder. So basically, what is the student doing? The student is filling the straw with water and then he is taking this straw to the measuring cylinder and emptying the volume here. Because the student is doing what? Student पूरी की पूरी straw में पानी भर रहा है पहले. Then he is taking this straw to the measuring cylinder and emptying the water in the measuring cylinder. Perfect. The student repeats the process 4 more times for a total of 5 transfers. ठीक है. Figure 1.3 shows the total volume of VT in the measuring cylinder. Okay. Write down the value of VT. Okay, so we have to read this reading of VT. So this is 20, this is 21, 22, 23, and 24. VT is what? 24 cm cube. Simple. Calculate the average volume of V2 in one straw. Can you realize that this volume total in the measuring cylinder is of what? Is of 5 transfers. बेटा ये वॉल्यूम टोटल जो आया है वो 5 ट्रांसफर का आया है. दिस इज अ 5 ट्रांसफर्स. हाउ विल यू कैलकुलेट द एवरेज वॉल्यूम इन वन स्ट्रॉ? 24 divided by 5. This comes out to be 4.8 cm cube. Perfect. Let's further move ahead. Suggest two reasons why V1 and V2 are different. Okay. V2 is 4.8. V1 is 5.3. Why are these two values different? There can be multiple reasons to it. Do you like to suggest any reasons here? Yes. Yes. What would you like to suggest here? How are V1 and V2 different? First difference is pretty evident. Can you realize the volume V1 that we have measured is the external volume because we have measured these external diameters and then we have measured the external volume in V1. However, for V2 we have tested how much water can be carried in this straw. For V2 we have tested how much water can be carried in this straw. Basically V2 is what? V2 is the internal volume. V1 is what? V1 is your external volume. So obviously external and the internal volume will be different. Why? Because the straw has this material which it is made up of. बेटा straw की ये thickness देख रहे हो छोटी सी. This is a material that the straw is made up of. Hence the internal and external diameters will not be same. They will be different. Hence why the difference between V1 and V2. So you can say V1 is the external diameter or the external volume. External volume. However, V2 is what? V2 is the internal volume. Hence they are different. बेटा V1 क्या है external volume, V2 is the internal volume, hence they are different. What is another difference you can say here? It is completely possible that the straw might not be completely filled. It is completely possible बेटा कि straw यहाँ पे ends पे जो है वो unfilled रहे. So this can also be a reason for the differentiation between V1 and V2. You can say the straw is not completely filled. Is not completely filled. Any other reasons here? Any other reasons that you guys would like to suggest? और क्या reasons हो सकते हैं? Any other reason? It is possible that the straw becomes squeezed or something like that. You can say the straw can become squeezed, can be squeezed. You can also write one more interesting point here. You can also write one more interesting point here. You can say that there can be air bubbles inside the straw, which reduces the volume of water which the straw can carry. You can write there can be air bubbles inside the straw, inside the straw, which reduces, which reduces the volume of water the straw can carry. The straw can carry. Simple as that. What else can you write here, beta? Any other thing that you can write here? I guess these are enough, right? These are enough. Four differences हमने लिख दिए हैं. वैसे भी दो देने थे. We have written more than enough. Let's see this. A student investigates series and parallel combinations of resistors. Perfect. The student is provided with two resistors X and Y. Perfect. Connected in the circuit shown in figure 2.1, the resistors are not identical. The electromotive force of the power supply is 3 volts. Okay, so we have 3 volts power supply here. The student closes the switch. Okay, so you are closing this switch like this. Perfect. Figure 2.2 shows the voltmeter reading Vx, okay, and Is on the ammeter. Perfect. So we have a current reading Is on the ammeter and voltage reading Vx on the voltmeter. Record the readings of Is and Vx. Perfect. So beta, what will be the voltmeter ki reading? If I zoom in here, what will be the voltmeter ki reading? Can you realize this is one? Yeah. This will be 0.2, 0.4, 0.6. This is 0.8. Your needle lies exactly between what? बेटा जो आपकी needle है वो कहाँ lie कर रही है? If I erase all this distraction, this is 0.8 and this is 0.6. Your needle lies exactly in the middle, that is 0.7. You can write it here. This is 0.7. What about the current? If you analyze, this is 0.5. This is 0. This will be 0.1, 0.2, 0.3, and 0.4. If you realize the needle is lying exactly in the middle between zero point 0.2 and zero point 0.3, the current will be what? 0.25 ampere. The current will be 0.25 ampere. Perfect. Now, the student opens the switch. Perfect. The resistance of a resistor can be found out using this equation. Voltage across the resistor divided by the current in the resistor. What is the voltage across the resistor, beta? 0.7. Current क्या है? 0.25. कर दो divide. 0.7 divided by 0.25. What does your resistance comes out to be? Resistance comes out to be 2.8 ohms. Nothing complicated. Can you realize how easy ATP papers are? Can you even imagine that the examiner gives you this formula, resistance is equals to VI in the theory? No. ATP papers are inherently easy. Suggest why the switch is opened after the readings of potential difference and current are recorded. Now, this is a good practice. Whenever you have taken the readings from the voltage and the ammeter, you always open the switch. Why? To prevent overheating of the resistors or to prevent overheating of the circuit. You can write it here. To prevent overheating, overheating of resistors slash circuit. Nothing complicated here, bhai. चलो आगे बढ़ते हैं बेटा. The student disconnects the voltmeter and reconnects it across the resistor Y. अच्छा अब आप voltmeter को कहाँ लगा रहे हो? Across resistor Y. Somewhat like this. चलो let's see. Okay. The potential difference Vy across Y is given by this equation. Okay, voltage across Y is given by this equation. Use this equation and your value of Vx to calculate Vy. अच्छा Vy किस तरह आएगा भाई? Vy is equals to 3 minus Vx. Vx क्या था? 0.7. Perfect. 3 minus 0.7. This is equals to 2.3 volts. Perfect. This is equals to 2.3 volts. You also have to calculate the resistance value of R. Why? Beta, how will you calculate the resistance value? The voltage across Y divided by the current across Y. Do you have the voltage across Y? 2.3. What will be the current across Y? Can you realize this is a series circuit? Can you realize this is a series circuit? The current across X was what? The current across X was, I guess, 0.25. Yeah, 0.25. The current across X was 0.25 ampere. तो बेटा करंट अक्रॉस वाई भी क्या होगा? 0.25 एम्पेयर. दोनों ब्रांचेस में करंट सेम रहेगा और यू कैन से इन अ सीरीज सर्किट द करंट रिमेन सेम. So you will divide it by what? 0.25. कर दो भाई divide. What does your answer of resistance comes out to be? Your answer of resistance, let me write it here. Your answer of resistance comes out to be 9.2 ohms. 9.2 ohms is your answer of resistance. Perfect. आगे बढ़ते हैं बेटा. The student now connects X and Y in parallel. Oh, interesting. The question is getting interesting. Let's see. The student now connects X and Y in parallel. Perfect. Complete the circuit diagram in figure 2.3 to show the two resistors connected in parallel between points W and Z. Draw the voltmeter to measure the potential difference Vp across both resistors. Okay. So first of all, you have to connect both the resistors in parallel. Okay. So you have X and Y. Okay. You will connect it in parallel like this. You can connect them in parallel like this. X and maybe create another branch like this. Why? The job is not done. You also have to do one more thing. As far as I have noticed, you also have to do one more thing. You have to do what? Draw the voltmeter connected to measure the potential difference across both the resistors. You also have to draw the voltmeter as well. How will you draw the voltmeter? Voltmeter is always drawn in parallel. Like this. Voltmeter is always drawn in parallel like this. This marks the end of your question. दो रेजिस्टर्स आपने पैरेलल में बना दिए, वोल्ट मीटर भी आपने पैरेलल में लगा दिया इनके अक्रॉस. सिंपल. Oh, we have some other question as well. Theory suggests if two resistors are arranged in parallel, then the combined resistance RT is given by this. Use the equation and your value of Rx and Ry from ठीक है, A2 and A4 to calculate RT. Okay, so you have to calculate RT. What was Rx? Did we calculated Rx? मेरा ख्याल है we calculated it. Rx was 2.8. Yeah, 2.8 is Rx. Perfect. What was Ry? I guess we calculated this as well. As far as I can remember, 9.2. Yeah, 9.2. You have to calculate RT. Beta, how will you calculate RT? Easy peasy. Rx 2.8 into Ry 9.2 divided by Rx, that is 2.8 plus 9.2. What does this answer come out to be? 2.8 into 9.2. 2.8 plus 9.2. This gives you a value of what? This gives you a value of 2.15 ohms if you want to give it till three significant figures. बेटा अगर आपने आंसर टू सिग्निफिकेंट फिगर्स पे देना है देन इट इज 2.1 ohms. This is also correct. Both answers will be marked correct. Don't worry about it. Let's further move ahead. The manufacturer suggests that the combined resistance of X and Y placed in parallel should be 2.5 ohms. Perfect. Now, this is a regular question. This is an FAQ of the examiner. Please see how to solve this. Okay. Two quantities can be considered to be equal within the limits of experimental accuracy if their values are within 10% of each other. Perfect. So, beta, two values are considered to be accurate if they are within 10% of each other. State whether your value of RT has the same value as suggested by the manufacturer. Support your statement with a calculation. So बेटा हो ये रहा है, if I explain you in simple terms, मैन्युफैक्चरर कह रहा है कि आपकी रेजिस्टेंस टोटल की वैल्यू होनी चाहिए 2.5. ओके, आपकी रेजिस्टेंस टोटल की वैल्यू क्या आ रही है? योर रेजिस्टेंस टोटल की वैल्यू इज 2.15 ओम. आई एम टेकिंग थ्री सिग्निफिकेंट फिगर्स. ओके, आई एम टेकिंग थ्री सिग्निफिकेंट फिगर्स. आपकी रेजिस्टेंस टोटल की वैल्यू आ रही है 2.15 ohms. You have to tell whether this value which you have calculated with experiment is justifiable or not. Now always remember this question is solved using a specific method. वही method आपने लगाना है. अगर आप लगाओगे आपको full marks मिल जाएंगे. You have to calculate the percentage difference. You have to calculate the percentage difference in R. How will you do that? Larger value of R minus the smaller value of R. And this applies to every variable. Larger value of R divided by minus the smaller value of R divided by what? Divided by the R average. Now, how will you calculate R average? Very, very easy. R average is what? R की larger value plus a smaller value divided by 2. So these two formulas you need to remember. Let me write it in a variable format that can be applied everywhere. Whenever you have such type of questions, you have to calculate the percentage uncertainty in the variable x. How will you calculate the percentage uncertainty in variable x? Larger value of x minus the smaller value of x divided by the average value of x multiplied by 100. Did I multiply it by 100? No. Okay. Multiply this by 100. For R, we will do this. Okay. Now here you will easily know what is the larger value of x, what is the smaller value of x. How will you calculate x average? X average is equals to what? X larger value plus x smaller value divided by 2. Perfect. Let's apply this formula. Okay. First of all, let's calculate R average. Let's first of all calculate R average. So R average क्या होगा बेटा? 2.5 plus 2.15 divided by 2. Let's calculate this. 2.5 divided by 2. This comes out to be 2.3. Our average comes out to be 2.32 ohms. Let's do it till 3 seconds. Okay. You have your R average out of the way. I have applied this formula. Perfect. Nothing complicated. Now let's calculate the percentage uncertainty in R. Perfect. Now percentage difference in R will be equal to what? R larger, that is 2.5, minus R smaller, that is 2.15, divided by 2.32 multiplied by 100. Can you calculate this answer, guys? 2.5 minus 2.15 divided by answer multiplied by 100. The percentage uncertainty comes out to be what? 15%. I am again and again saying percentage uncertainty. Pardon me. That is just percentage difference. That is just percentage difference. If you realize you have a percentage difference of 15%, this is greater than 10%, hence you will reject your answer. You can write this as a journal rule here as well. If the percentage difference is greater than 10%, reject. If the percentage difference is less than equal to 10%, accept the hypothesis, or you can say accept what the examiner is saying, or accept the values, or you can say the values agree, whatever you want to say. 1 second, let me make it much better for you guys. एक और काम कर लेते हैं यहाँ पे. Let's do one thing. If the percentage difference in x is greater than 10%, what will you say? You will say the values do not agree. Values are not same. Values are not same. If the percentage difference in x is less than equal to 10%, the values are same. Simple as that. I have made this question easiest for you guys. Now, you can write this here. You can say, since percentage difference, percentage difference is greater than, is greater than 10%, the values are not same. The values are not same. Simple as that, nothing complicated. If you have any questions, you can ask right now. Let's further move ahead to the next question. This one, channel, let's see this. A student does an experiment to find the mass of a meter rule. Okay, so a student does an experiment to find the mass of a meter rule. Perfect. A fixed mass is placed at the meter rule at a 5 centimeter mark as shown in figure 3.1. ठीक है, ये एक fixed mass placed है at a 5 centimeter mark. ठीक है. You have a pivot at 25 centimeter mark and you have a meter rule. You have a bench. Perfect. The student places the pivot at the 25 centimeter mark as seen from the diagram. He places a mass of 20 grams on the meter rule. Perfect. Adjust the position of the 20-gram mass until the rule is as close to balance as possible. So, okay, the student is placing another 20-gram mass here, adjusting the mass key position until the rule gets balanced. Perfect. The position of the 20-gram mass when the rule is as close to balance as possible is shown. Perfect. So, this is the 20-gram mass on the meter rule. Perfect. Use figure 3.2 to determine the distance d of the 20-gram mass from the pivot when the meter rule is as close to balance as possible. You have to determine the distance d of the center of the 20-gram mass. First of all, you have to find the center of the 20-gram mass. How are you going to do that? Easy peasy. How are you going to find the center of the 20-gram mass? If you realize, this is what? This is the first point. Oh, let me choose a thinner marker. If you realize the 20-gram mass is starting from this point, that is 81.81, and it is ending at maybe this point, that is 82.9. How can you calculate the center, beta? How can you calculate the center of the 20-gram mass? Now you can make a key point again here. To calculate the center, what will you do? Let's say this is your starting position. Let's say this is your ending position. To calculate the center, what will you do? The starting position plus the ending position divided by 2. What is the starting position? 81.1. What is the ending position? 82.9 divided by 2. Let's calculate this. 81.1 plus 82.9 divided by 2. This gives you an answer of 82. So the center of this mass is at the 82 centimeter mark. Okay. The center of this mass is at the 82 centimeter mark. What do you have to calculate? You have to you have to calculate the distance d of the center of 20 gram mass from the pivot when the meter rule is close to balance as possible. Okay. So we know that the 20 gram mass is at 82 centimeter. Where was the pivot? The pivot was at 25 centimeter का mark. Pivot कहाँ पे था बेटा? 25 centimeter के mark पे. What will be the distance d between the two? 82 minus 25. This equals to what? 82 minus 25. This equals to 57 centimeter as your answer. 57 centimeter is the distance between the pivot and the mass. Let's further move ahead. Describe this technique the student uses to balance the meter rule with the 20 gram mass. Okay. What technique will the student use to balance the meter rule with the 20 gram mass? बेटा ये तो बहुत easy है. ये तो बहुत easy है. You will do what? You will move the 20 gram mass backwards and forwards slowly along the rule until the rule is balanced. You can write it here. Move the 20 gram mass. Move the 20 gram mass backwards and forwards along the meter rule. You can also write slowly here. Move the 20 gram mass backwards and forwards slowly along the meter rule until the meter rule is balanced. Until the meter rule is balanced. Simple as that, nothing complicated. Let's further move ahead. Let's see this. The student repeats the procedures for values of mass m is equals to 30, 40, 50, and 60 grams. Perfect. Table 3.1 shows the results. Perfect. Add your value of d when m is equals to 20 gram. What was the value of d? 57. Perfect. Calculate 1 over d for each mass and record all the values in the table 3.1. Give your answers to an appropriate number of significant figures. Now realize something. Realize something. Can you see, can you observe, can you guys humbly observe that the values of d are in two significant figures? Beta sari ki sari values of d are in two significant figures. So all your values of 1 over d, all your values of 1 over d will also be in two significant figures. So if I calculate the first value of 1 over d, that is 1 divided by 57. If I calculate 1 divided by 57, this comes out to be what? 0.0175. I cannot write this. I cannot write this entire value. This is three significant figures. I will have to convert it till two significant figures. 0.018 can be my answer. बेटा अगर आपकी d की वैल्यू टू सिग्निफिकेंट फिगर पे है तो आपने 1 ओवर d की वैल्यू भी टू सिग्निफिकेंट फिगर्स पे रखनी है, बस ज़्यादा नहीं देने से. ठीक है. नाउ 0.018 इज योर आंसर. सिंपल हियर. ठीक है. नाउ सर हाउ डिड यू मेड इट 8? अच्छा सर आपने यहाँ पे 8 क्यों कर दिया? बिकॉज कैन यू रियलाइज बेटा कि दिस वैल्यू द थर्ड डिजिट is greater than equal to 5. It is 5 or it is greater than 5. So I have to add 1 in the second digit. I have to add 1 in the second digit. You will always keep your values till two significant figures. अगर आपका d की वैल्यू टू significant figures पे 1 over d की वैल्यू आपने टू significant figures पे ही रखनी है, उससे ज़्यादा नहीं देनी. Let's try out another thing. Let's do 1 over 37. 1 divided by 37. This comes out to be 0.02702. I will not write all this. I will just pick the first two significant figures 0.027. 0.027. Now, most of the students will be well aware with this point, but अभी भी अगर mathematics में ये point नहीं पढ़ा बेटा तो आप पढ़ लो that zeros before a non-zero digit. Zeros before a non-zero digit are not significant. बेटा ये वाले जो जीरो मैंने हाईलाइट किए हैं दे आर नॉट सिग्निफिकेंट, ये एक नॉन जीरो डिजिट से पहले है। नॉन जीरो डिजिट क्या होता है, 1 2 3 4 5, इस तरह के जो भी नॉन जीरो डिजिट्स होते हैं उनसे पहले अगर जीरो होता है तो दैट इज नॉन सिग्निफिकेंट। आई होप यू रिमेंबर दिस फ्रॉम मैथ्स, दिस जीरो इज नॉट सिग्निफिकेंट। लेट्स डू 1/28। 1/28 का क्या आंसर आता है भाई? 1/28 is 0.0357. Again, you cannot write this entire thing. You will say 0.036 only. Simple. Let's do 1 divided by 22. This comes out to be what? 0.045. Let's do 1 divided by 18. This comes out to be 0.056. Perfect. These are your answers, and if you don't believe me, you can check in the marking schemes as well. You will get the same answers, inshallah. Chalo, let's move ahead. Suggest why a value of D for M is equals to 10 grams cannot be found. Just suggest why a value of D cannot be found for M is equals to 10 gram. Okay. So can you realize one pattern here? Can you realize one pattern here? As the mass is decreasing, the value of D is increasing. The value of D is increasing. So if you choose a value of, let's say, 10 grams, then your distance D will go out of the meter rule. Beta distance D itna bachega hi nahi, it will go out of the meter rule. You can say here that if we take mass as 10 gram, there will be no balance point, or you can say D will be outside the meter rule. You can say if mass is equals to 10 grams, the value of D will be greater than 75 centimeter. Why I am saying greater than 75 centimeter? Because beta, can you realize pivot आपका 25 centimeter पे, remaining length क्या है? Remaining length of this meter rule is 75 centimeter. If you place a 10 gram mass, your D will be greater than 75 meter, and no balance point, and no balance point on the meter rule. No balance point on the meter rule. Simple as that. Nothing complicated here. आगे बढ़ते हैं बेटा. Use the grid provided on figure 3.3. Okay, so we have to use the grid provided on figure 3.3 to plot a graph of 1 over d on the y-axis against m on the x-axis. Perfect. Now the examiner has already provided you that start the origin from 0, 0. Perfect. Draw the straight line of aspect. Perfect. So you have to plot 1 over d on the y-axis, mass on the x-axis. Perfect. Let's go to the graph. First of all, mark the axis 1 over d slash, what are the units? Centimeter minus 1. Okay, 1 upon centimeter. 1 upon centimeter can be written as centimeter minus 1. There are no harms to that. Please avoid writing on the barcode like this somewhat. Okay. You can make it further smaller. Put it here. Okay. Not on the barcode, you can put anywhere else. Now, on the x-axis, you can mark the mass slash grams. Simple. Now, the examiner has already told you that you have to start your axis from the origin, 0 and 0. Perfect. Okay, now, how will you plot the complete scale? बेटा ये remaining scale किस तरह plot करोगे? How will you plot this remaining scale? Easy, very easy. Can you realize you're starting from 0, 0? You're starting from origin. Perfect. First of all, realize the x-axis. First of all, realize the x-axis. On the x-axis, you have a maximum value of 60. You have a maximum value of 60. What is the minimum value? Not 20, because you are starting from 0. Your minimum value will be 0. Now keep these in mind. Count the number of large boxes on the x-axis. 1, 2, 3, 4, 5, 6, 7, 8. There are 8 large boxes on the x-axis. Perfect. And your minimum value on the x-axis is what? Minimum value on the x-axis is 0. Maximum value on the x-axis is 60. Now, what will you do? How will you calculate the scale? Very, very easy. To calculate the scale, what do you do? To calculate the scale, what do you do? Maximum value minus minimum value divided by the number of boxes. Divided by the number of boxes. What are the number of boxes? These large boxes. 1, 2, 3, 4, 5, 6, 7, 8. What is the maximum value? 60. Minimum value is 0. Number of boxes is 8. Perfect. What does this comes out to be? 60 divided by 8. This is equals to 7.5. Okay. So 7.5 boxes की scale होनी चाहिए. Like every box should represent 7.5, 15. That is what we are getting with the calculation. But here you have to apply some common sense. You know that if you take one box as 7.5, that will be an awkward scale. That will be an awkward scale. What can you do? You can say one box is equals to 10 units. You can take this as your scale. Let's plot this on the x-axis. Let's plot this on the x-axis. Let's say this is 10. Let's zoom in a bit. Let's say this is 10, this is 20, 30, 40, 50, 60, 70, and 80. Perfect. Now let's do the same thing with the y-axis. On the y-axis, what is the maximum value? The maximum value is 0.056. Okay, let's write a small maximum here. The maximum value on the y-axis is 0.056. Perfect. So let's write it here. On the y-axis, your maximum value is 0.056. What is the minimum value on the y-axis? Again, 0. Okay. What are the number of boxes on the y-axis? What are the number of boxes on the y-axis? Let's count them. One large box, two large box, three, four, five, six, seven, and 8, 9, 10, 11, 12. Okay. So 12 large boxes on the y-axis. Perfect. So what are you going to do? Easy peasy. What are you going to do? You are going to say that the scale on the y-axis will be equal to what? Y maximum 0.056 minus 0 divided by 12. This comes out to be what? 0.056 divided by 12. This gives you a scale of what? This is 2 in decimals. This gives you a scale of 0.0046. Now you know this scale cannot be plotted. This is an odd scale. What will you plot? You will say each big box or each large box represent 0.05 on the y-axis because that is a good number, or you can say that is a scale that will be readable. So let's start plotting this. Let's start plotting this. This will be 0.005. This will be 0.01. Okay. I guess we have to go very carefully because there are many zeros here. This will be 0.015. Perfect. The next one will be 0.02. Perfect. Let's erase this. This will be 0.025. Perfect. This will be 0.03. Perfect. And this will be 0.035. Perfect. This will be 0.04, 0.045, and the last one. I guess the last one, this will be 0.05. This will be what? This will be 0. Okay, we have an interesting little problem here, 0.055. Okay, we have an interesting little problem here. Can you see the 12th box is only half? तो कैन यू रियलाइज कि जो 12th बॉक्स है वो सिर्फ हाफ मार्क्ड हुआ हुआ है. नाउ व्हाट डज दिस टेल यू? व्हाट डज दिस टेल यू? इसका मतलब ये है कि आप यहाँ पे, ओहो, okay, can you see the 12th box is only marked half? Okay. What was the maximum value that you wanted? The maximum value that I wanted was 0.056. Okay. Can I get that maximum value here? Let's see. Let's see. If I can get that maximum value here, the scale will be valid. If you notice, if you notice, you are covering, you are going from 0.05 till 0.055. Basically, you are covering how many units? You are covering from here till here. You are covering how many units? You are covering 0.005 units. And how many boxes are you taking? You are taking 10 boxes. So let's do a little calculation here. 0.005 is covering 10 boxes. Perfect. One box will be equal to what? One box will be equal to what? 0.0005. Please, please remember this. One box is equals to what? 0.005. Perfect. Now, if you analyze here, if you go two boxes above, if you go two boxes above, what will two boxes represent? 2 multiplied by 0.005. This is equals to what? 0.001. This is your representation by two boxes. If you add 0.001 to what? 0.055. What will your answer come out to be? 0.056. So yeah, this is your maximum value, 0.056. That is present on the graph. The maximum value is present on the graph. You don't need to adjust your scale. The maximum value is present on the graph. You don't need to adjust your scale. Let me not erase that working. Let's keep it somewhere here to the left. Yeah. Now, you have gotten 3 marks. Oh, sorry, 2 marks up till now in the graph ka question. This is a 4 marks a graph ka question. You have gotten 1 mark for marking the axes and you have gotten 1 mark for plotting the scale. Now let's move on to the third mark. Now I will speed up the video because this is just graph plotting. I will just plot these points on the graph and will show you in a bit. Okay, so I have plotted the points as you can see here. Let me zoom out a bit. Yeah, these are the points. Now you have to draw a line of best fit. Now you have to draw a line of best fit. What is a line of best fit? Line of best fit is a line that passes. Line of best fit is a line that passes through maximum number of points and has equal number of points above and below. So here we have 5 points. We will try to pass this line of best fit through at least 3 points and make sure that 1 point is above and 1 point is below. If you have 5 points, you try to pass your line of best fit through at least 3 points and make sure 1 point is above and 1 point is below. Let's try and do it. Okay, so this is a line of best fit. Can you realize the line of best fit is passing through 3 points? Which 3 points? One, two, three. 1 point is above the line of best fit, that is this point. 1 point is below, that is this point. If you look closely, you will find out that this is below the line of best fit. Okay, so this is your appropriate line of best fit. Now, let's move on to the next part. क्या करना है next part में? We have to calculate the gradient of your line. Now, this also has some key points. You have to calculate the gradient of your line, show your working, and indicate on the graph the value that you use. First of all, whenever you are calculating the gradient, you will take 2 points that are 50% apart. You will take 2 points on the line that are 50% apart. Which 2 points can I take here? Which 2 points can I take here? Maybe let's say this point. Let's say this point. This point was the first point. This was 20 and 0.018. Perfect. Which second point can I take? Maybe this point. Yeah, we can take this point. Make sure your points are furthest apart. Make sure your points are furthest apart. Let me choose this point. ये अच्छा point लग रहा है. Let's choose this point. This one. This is x-axis 60 and y-axis this will be, on the y-axis this will be 0.0. Let me check it out. 0.0545. This will be 0.0545. Sir, how did you did this magic? Very, very easy. I think I have did the calculation that each box is equals to what? 0.0005. So I have done what? I have subtracted 0.0005 from 0.055. I have just see what have I done is 0.055 same and 0.0005 minus can be. You get your answer as what? 0.0545. Simple. You can do this in the calculator as well, I guess. Let's do it. Let's verify it. Yeah, you are getting the same answer. I hope this is clear. Now you have the 2 points. First of all, it is advisable. Now you draw it or not, but it is advisable to draw a triangle with the points of your gradient. It is advisable that if you have a time, draw a triangle with the points of your gradient. Yes, you heard me right. It is advisable to do that. The examiner finds it much easier to view your points if you have drawn a triangle here, somewhat like this. And you can extend this towards the downside. 1 second. You can extend it towards 0.18 like this. Perfect. And yeah, you can make this as your triangle as well. Perfect. Now let's make them dotted since the triangle needs to be dotted. 1 second. Yeah. And obviously it should not overlap like this. Can I remove that? Yeah. Very good. Very good. OneNote is behaving very good today. Shabash. This is something that is advisable to do. If you don't do it, I don't guarantee a marks deduction. I don't guarantee a marks addition, but this is advisable to do. Perfect. Now you have 2 points here. Perfect. Let's write those 2 points. The 2 points are 60 and 0.0545 and 20 0.018. Perfect. Now you have to calculate the gradient of your line. You have to calculate the gradient of your line. How are you going to do that? Easy peasy. You will also write the formula of gradient. Gradient is equals to y2 minus y1 x2 minus x1. Perfect. What is y2? Let's say this is your y2, 0.018. This is your y2, this is your x2, this is your y1, this is your x1. y2 minus y1, that is 0.0545 divided by 20 minus 60. What does your answer comes out to be? 0.018 minus 0.0545 divided by 20 minus 60. This comes out to be 9.125 into 10 raised to the power of minus 4. But as I have told you, you can write your answers till two significant figures or three significant figures. So I will keep it up till here. Simple. 9.1 into 10 raised to the power of minus 4. Simple as that, nothing complicated. Let's further move ahead. You have to calculate the mass m of the meter rule. Mass m of the meter rule is equals to what? 160 minus 0.040 divided by g. That is 9.1 into 10 raised to the power of minus 4. Let's calculate that. 0.04 divided by the gradient. and 160 minus answer. This gives you a value of 116 grams as your mass of the meter rule. This gives you 116 grams as the mass of your meter rule. Let's further move ahead. Fix mass at 5 centimeter. Okay, 25 centimeter पे pivot है. यहाँ पे आपका molding clay है. Perfect. The student is given a piece of modeling clay. He places it on the meter rule as shown in figure 3.4. Perfect. He finds that the meter rule is balanced when the molding clay is at a distance of 40 centimeter from the pivot. Use your graph in figure 4. In 3.3 on page 13 to find the mass of the molding clay. Easy. If you are balancing it at a distance of 40 centimeter away from the pivot, D क्या हो जाएगा बेटा? D is 40 centimeter. What will be 1 over D? Let's calculate that. 1 divided by 40. This gives you a value of 0.025. 1 over D is 0.025. You have to calculate the value of mass at 0.025. So do we have it marked? Yes, 0.025 पे आप जाना and you can calculate this mass exactly in the middle. Let's see what is this middle value. This middle value. This is 27.5 grams. Perfect. How do I know that? Because 10 boxes are covering 10 units, so 7.5 boxes will cover 7.5 units. The mass of the molding clay is 27.5 grams. Simple as that. Nothing complicated here. Chalo. Let's move ahead to the next question, and the question that students find the most difficult, that is question number 4. Yeah, let's see this. A student uses ice cubes to investigate the time taken for different masses of ice to melt when the ice cubes are placed in water. Perfect. So, student uses ice cubes to investigate the time taken for different masses of ice to melt when the ice cubes are placed in water. Perfect. Plan an experiment using ice cubes to investigate how the mass of ice affects the time for the ice to melt. Perfect. So basically, we are doing what? We are taking different masses of ice and we are seeing the time taken for the ice to melt. Perfect. The following apparatus is available: top and ball supply of ice cube, 50 centimeter beaker. Perfect. Supply of cold water, stopwatch. Perfect. You may also use other apparatus. Perfect. If you need in a school laboratory. Explain briefly how you will carry out the experiments. State the key variables to keep constant. Draw a column with table headings. Explain how to use these readings to reach a conclusion. Simple as that. You do not have to include a diagram of the apparatus you use, but you may do so if it helps your plan. You do not have to include a diagram, but you can if you want to. Okay. So how will you do that? First of all, you will say, let's write this answer. You will say, measure the mass of ice cubes, or you can say measure the mass of different ice cubes using a top pan balance. Using a top pan balance. Perfect. Then what will you say? Then what will you say? If you see you have a beaker and okay. So what will you do? You will basically measure 100 cm cube of water using a measuring cylinder, using a measuring cylinder, and pour it inside the beaker and pour it inside the beaker. Perfect. तो बेटा बेसिकली मैं क्या कर रहा हूँ? What am I doing here? I am taking a measuring cylinder. Let's say this is a measuring cylinder. I am measuring a water up to 100 cm cube, and then I am pouring that water into the beaker. Why I am doing this method? Because बेटा बीकर पे कोई मेजर करने का मेथड इतना अच्छा होता नहीं. You always measure the water using a measuring cylinder and then you add it into a beaker like this. Simple. So your beaker will be containing 100 cm cube of cold water. Perfect. Okay. And this is your measuring cylinder. Simple. Measuring cylinder. Chalo, let's move ahead. Let's further move ahead. What will we do next? What will we do next? You will say, add ice to the water. You will say, add ice to this water. Add your ice cube here. You can immerse the ice cube fully inside the water. Maybe like this. Add your ice cube to the water. Simple. Although you don't need to draw this diagram, the examiner will understand what you are writing. You can say, add ice to the water and start the stopwatch and start the stopwatch. Simple. What will be your next step? You will say stop the stopwatch. Stop the stopwatch as soon as ice melts completely. Stop the stopwatch as soon as the ice melts completely. Simple as that. What is a thing that you have to write always? This is a key statement that you write always. Repeat the experiment with different masses of ice. Repeat. You always write about repeating the experiment. Repeat the experiment with different masses of ice. Repeat the experiment with different masses of ice. Perfect. Now, last statement. Lastly, what you will tell. Can you see that the examiner has asked you to tell what are the key variables that you will keep constant? The initial volume of water that you are pouring in the beaker will be remaining constant. The initial temperature of this water will remain constant. These are some variables that you can keep constant. You can say the initial volume of water in the beaker and the initial temperature of water in the beaker of water in the beaker should remain constant. In the beaker should remain constant. Simple. Nothing complicated here. Lastly, what is the examiner asking you? Draw a table with column headings to show your readings. Okay. So how do you draw a table? Very, very easy. How do you draw a table? Draw a table like this. What will be the column headings? What will be the column headings? Mass of ice cube slash grams and time taken to melt slash seconds. Perfect. Okay. Explain how to use these readings to draw a conclusion. How will you utilize these readings to draw a conclusion? You can say two things here. बेटा अब यहाँ पे आप दो चीजें कह सकते हो. You can write two things here. You can say plot a graph. This can be your first statement. You can say plot a graph of mass against what? Mass against time taken to melt. Not a graph of mass against time taken to melt. Perfect. This can be one conclusion. This can be one conclusion. And another conclusion can be, you can say, compare the readings, or you can say, compare the readings. This can be your other. You can write either or. Either you can write this conclusion or you can write this conclusion. Or if you are over efficient, you can write both the conclusions. Compare the readings and observe if the mass of ice cubes. Compare the reading and observe if the mass of ice and observe if the mass of ice cubes affects the time taken to melt. Affects the time taken to melt. These are the two conclusions that you can write here. Compare the readings to see if the mass of ice cube does affect the time taken to melt. Simple as that. This marks the end of paper. If you have any questions, you can ask in the chat or the comment box.